Okay, RA example 3 gives you another data table about a particle moving along a horizontal line with this velocity. So they gave you the velocity in the table, and one says use the data from the table to approximate the distance traveled by the particle. Now this is the velocity and that's time, so if we want to go backwards and take the integral of that, which would be a Riemann sum, we would just get centimeters. So it says, so use the data in the table from 0 to 10 by using a right Riemann sum with 4 subintervals. So no average or anything, you're going to get a total, shows the computations and indicate units of measure. Make sure you read all about it. Okay, so right Riemann sum. First thing we're going to do, it's 4 subintervals, so we have to calculate delta t. This would be 2. This is 3, 2, 3. So they're all uneven, and it's a right Riemann sum, so we're going to remember to circle the right-hand ones, 6.8, 7.4, 15.6, and 24.9. So you would say distance traveled, use approximately because you're doing a Riemann sum. It would be 2 times 6.8 plus 3 times 7.4 plus 2 times 15.6 plus 3 times 24.9. You've done these enough. You should be able to calculate with that without a problem. And that's approximately equal to 141.7 centimeters. That's the distance it traveled using a right Riemann sum. All right, let's look at part 2 of this example. All right, it gives you another particle moving along the same line with acceleration, notice centimeters per second squared, and at time t equals 1, the velocity is 13. So they're going to give you an initial value for velocity, and it goes, which particle is traveling at t equals 5 seconds faster? Which particle is faster? Well, you have right here the velocity of particle A is 7.4 at t equals 5. So you know that one. So you just have to calculate the velocity at t equals 5 for particle B, and you were given acceleration. To get to acceleration, what do you do? What do you do? You go backwards, right? So let's say what we know so we can do this, that the velocity of particle B in terms of t is equal to the integral of the acceleration of B in terms of t dt, which is then the integral of 2t minus 7 dt. Okay, and then we're going to calculate that to be t squared minus 7t plus c, and that's where this t equals 1 second, and when it's 1, the velocity is 13. So we have a point 113 to put into the equation to find c. So we'll say 13 equals 1 minus 7 plus c, or 13 equals negative 6 plus c, so c equals 19. So our velocity equation is VB of t is equal to t squared minus 7t plus 19. So VB of 5 is equal to 25 minus 35 plus 19. That's negative 10 plus 19. That's equal to 9. And remember what we're getting. We're getting centimeters per second. So because 9 is greater than 7.4, particle B is moving faster at t equals 5 seconds. All right, so those are your 3 examples, and you now have a worksheet to do for homework. Make sure you do that and upload it, and I will post the answers tomorrow. Okay, so give you a day to work on it, and then you can check the answers tomorrow.